We're going to start by kind of telling you about ourselves and where we are and our involvement in the proof course. I'm Connie Campbell. I teach mathematics at Millsaps College in Jackson, Mississippi. Our course is designed specifically to teach students how to read, write, and understand proofs. It's not a content-based course at all. The primarily begins with the study of logic and then covers proof techniques and then introduces more complex things such as functions and sets and tries to build the students up to increase their abilities to become more abstract thinkers and to apply those proof techniques outside of kind of algorithmic methods. I've been teaching the course myself since, I guess, the late 1990s. And kind of, I think all three of us came to this having a little trouble teaching that course. So that's really why we're here. Is we still don't think we have it all figured out, but we've certainly thought about it a lot and have some ideas that we want to share.
Hi, I'm Kay Summers from Moravian College, which is a small liberal arts college in Bethlehem, Pennsylvania. And I've been teaching various iterations of the proof course for about 25 years. The current iteration has a discrete math content focus. It's required of all mathematics and computer science majors, and it has a Calculus 2 prerequisite. It's also designated a writing intensive course, which means in addition to writing proofs, students need to write for different audiences and have some other writing requirements as well. And so it does double or triple duty, which makes it a challenging course to teach. I came to this project about the same time that Connie and Jim did, and because I wanted to have more variety in the teaching that I did in this course.
And I'm Jim Sandifer. I teach at Georgetown University, which is a large Jesuit college. And I started teaching the proof course about 15 years ago. When I started teaching it, I had difficulty because doing proofs was sort of automatic and the students just had no clue where I was getting the ideas for the proofs that I was doing. So working with a center on campus, I started what's called Think Alouds. So I started videotaping my students as they tried the homework problems. About the same time, I went to a math education conference and met Manya Raman, who's a math educator. And what she had been doing is videotaping grad students doing proofs because she thought they would be doing them more at a level of undergraduate students. And so her plan was to show the graduate students working proofs to the students in an undergraduate course. The problem was the grad students were still too far above the level of the undergraduate students. And so we started showing each other our videos, and she's the one that really had the idea of us videotaping the students that had been taking my classes and using those as ways of helping our students understand how to do proofs and because they would be working them more at a level of the students that are in the class. About the same time, I started giving some mini courses on proof, and the idea behind the mini courses was really for the people teaching the proof courses to share their ideas. And that's where I met Kay and Connie. And so the three of us and Manya applied for an NSF grant to the videotape students and develop this video library. So we had one NSF grant, which was sort of a phase one proof of concept, and we developed a small video library, and then we got a follow-up NSF grant, which is where this workshop is all about, because it's helped us develop a larger library. Now, in developing these video case studies, it was really helpful. We were working with Manya, who is a math educator, and so she was helping us learn about the issues, the research in math ed on students doing proofs and what the issues were with students learning how to develop proofs, where they get stuck, where the problems lie. So in doing this project, we have been based it on a lot of the current knowledge in the math education community about proofs. And we will share with you, we've developed a bibliography that we will put in a box in this where you can access it. And so if you want to see any of these papers, you'll be able to.
The focus of our project is really threefold. Primarily to promote student learning, to encourage metacognitive thinking on the part of students. And to do this, we developed some classroom resources. And then we've also used the resources that we've developed for faculty development to help faculty understand where student problems occur, what students are thinking as they try to develop proofs. The result of our project, we've produced more than 40 edited videos, which are currently on our website. And these videos have been edited down to about 5 to 10 minutes of good stuff. We edited out a lot of the parts that didn't produce anything, although we've included statements that show where students may have spent time and didn't get anywhere. And the videos are of students who have recently completed an Introduction to Proof course, working on statements that are new to them. And so they're speaking the language of the students.
And so we asked you, some of the issues you saw with students in regard to proofwriting, and we sent out kind of some of those as well as some of our own, but we came to the table with some very specific issues that we were wanting to address kind of in our initial stage of development. One of the first ones was that we all had experienced numerous students who understood a concept, understood why something was true, but just were unable to write that. And something that we thought, we tend to think of the hardest part as figuring out why a statement is true, kind of understanding the, we'll talk about what this term, but understanding a key idea. But we found out that even with that, that's not enough. Students really do struggle with how do I use the language of the discipline, to put this in a presentable form. Another thing we had a lot of trouble with was students understanding quantifiers, in particular multiple quantifiers, understanding variables when they're arbitrary yet fixed, or things like that. Certainly using new definitions. We want students to understand that the definitions can be used in the proofs, but what we very often see is a student will kind of develop a conceptual definition, and then they'll try to use that conceptual definition, and it will often get them into trouble. And we were concerned that students very often would just say they didn't have any idea what to do. So they don't know how to get started, or maybe something's not working and they didn't seem to have the working domain to be able to back up and try a new approach. So that was an issue we really wanted to try to see if we couldn't help students with. And finally, attention to detail. I'm sure y'all have had this as well, but I often have students who will say, oh, well, that's what I meant. They'll leave off something like X is an integer, and they'll turn it in and I'll count something off, and they'll say, oh, but you knew that's what I meant. That's obvious. And so that kind of paying attention to variables and what they mean and where they come from, some of that stuff was, we wanted to find a way to help students focus on that. And so in our attempt to figure out how we could help students, as we've said, what we did was we videotaped students working problems that were not trivial, right? They're a varying level of difficulty, but they're things that we thought students typically might have a little trouble with. The students had just completed a proofs course, so they had the working knowledge information from the course, but they had not taken subsequent courses, so they weren't well versed in proofwriting. So we had them work in pairs, and we videotaped this. And then we sat down and basically analyzed the videotapes to try to see places where the students got stuck, strategies the students attempted that either derailed them or helped them, things like this. So we spent a lot of time watching a lot of footage, trying to see what was going on with the students, what was causing trouble, or what was seeming to break through problems. And we took those videos, a number of them, and edited them down, as Kay said, to small clips that we can show in the classroom, or we can assign students for homework, and we have discussions about how the students in the video do things or don't do things, or what they try.